Are you ready for some science? I'm ready for McSteiger science. Yeah! Stand up and shout! Stand up and shout! Stand up, stand up, stand up and let it out. Stand up and shout! Stand up, stand up, stand up and let it out. McSteiger science.
Welcome to another episode of
McSteiger! Science.
Science.
We're science and metal
Combined.
Yeah.
Check out my shirt.
Yeah. I've been telling you that for a while.
Yeah, overreacting.
Cool. By the way, the draft locks still seem to have stolen my lab coat, so send in positive lab coat.
What are we gonna do today?
Today we're going to introduce you folks to an amazing concept that's going to blow your mind. It's called density.
Density, where you feel dense.
You do. Just
Yes.
saying the word, you're going to feel it. Try it. Try it.
Density.
Oh, that's great. Yeah, so I mean, basically, density is your stuff to space ratio, right? How much stuff can you cram into a particular density?
So you ready to
Sure, absolutely. We're going to have some fun today, folks. Steigerites, we have two amazing demonstrations planned for you today that are going to show you firsthand, without question, the concept of density in action. Are you ready for this? Technical difficulties. Pay no mind to the man who fell down in the back. You all right there, Steiger?
Yeah,
Okay.
just fixing our light.
All right. So our first demonstration for today is going to involve a variety of beakers filled with different fluids, different forms of water, if you will. Want to tell us what's in that one there? Alright, so our first experiment here is going to be a floating egg experiment, right?
Floating eggs?
Yeah,
How do you float eggs?
Can be done. You'll see what happens. It's
Whoa.
amazing.
That's awesome.
All because of density, right? So it's a basically simple experiment, and like any experiment, we've got some variables, and in this case, this is our control. Despite the fact that it's yellow and it may look like some other fluids you might be familiar with, it is in fact water.
Yellow water.
I'm not going to drink it to prove that, but it is water. With some food coloring in it.
Yellow
okay?
food coloring.
So what we're going to do now is we're just going to take an egg, straight up regular egg.
Yeah, absolutely, yeah. So I'm gonna just place it in the water and oh, it just dropped right down to the bottom. That's not floating.
No, it's not.
That must mean the egg is more dense than water.
That's exactly what that means, right? Because there's more stuff per unit volume in the egg than there is in the water.
All
so
right.
of course it sinks, right?
Perfect.
So now what we want to really do is try to manipulate the density, right? Now we can't really do anything with the egg itself to change its density, but we can totally mess with that water.
Oh, let's mess with the water.
Let's do it, okay?
All right.
Now, we're going to just go with some regular table salt here because it's going to dissolve nicely in there.
That nicely?
How do they always know? Yeah, absolutely.
How many?
We're going to put about 8 tablespoons of water, salt in the water. Just keep it coming. Oh, look at that. That's perfect. Wait, hey, slow down, okay?
Okay, sorry.
Okay, so stir that up and let's give it a chance to dissolve. So what we've done is we've added more mass to the water without changing the volume. So that's automatically going to raise the density of the water. Now the egg's density is going to be exactly the same.
You really think this is gonna float?
It should. If it doesn't, then I guess Chuck Norris has something.
All right, so I think that's about. It's in there. It's a big cloud. That's because it's very, very salty.
We've totally messed with the density now.
Now I want to add just some red food coloring so that we can. This looks cool.
Oh, totally.
Let's just try one because it is cloudy.
Oh, yeah.
Hey, Volcano. All right, so we think that this egg is going to float.
That's what the Steigerites have told me.
All right, let's try it.
Give it a shot.
Fingers crossed. Oh, John! Stop! That's floating!
Science!
Science!
Ooh, density!
Density! John! Stop! That's floating!
Science!
Science!
Ooh, density!
Density!
Gosh. So
Wow.
we were able to add enough stuff to this water that we altered its density and its destiny. Huh.
Destiny. The destiny is density. Its destiny is density.
See, that's
So,
intense, man.
what's our third one now?
Well, now we're just going to do something completely different. So we've taken some regular water again and added a whole whack load of salt. That's the official scientific measurement, in case you're wondering.
Whack load.
Yeah, so basically what we're going to do now is we're going to place some egg in there, and we're going to predict that it will what, Steigerites?
Float.
All
We
right.
actually do have an audience this time.
That's amazing.
All
Look at that.
right.
I love science.
Now, so it's floating.
It is, yeah.
It is
Just,
floating.
just as we predicted.
Have you ever wondered?
Yeah. Yeah.
So I'm gonna now add this yellow water, right?
Absolutely, because this is just regular old water now, just like here. So what we're gonna do is we're gonna see if we can actually get this egg to float in the middle.
Float in the middle.
I know, to hover in between the two different densities of water.
Whoa,
I know,
this is
this is
tense.
crazy.
This is Hulkamania.
Hold your breath, folks.
Look at that. The egg is in the middle.
And you can even see like a band where there's the yellow water on the top. The
You
red.
can, eh?
Look at that.
You can see the yellow and the red layer. It's kind of meshed together in the middle too.
Which
Whoa.
is, so that means the middle band is basically the same density as the egg.
Whoa.
Man, I totally didn't think.
All right, let's get on to the next density
Let's
demonstration.
do it.
All right, so I guess. Oh, by the way, so I just proved like we're magicians here.
Did you see that?
Just like that, in blink of an eye, we've changed our attire.
It's amazing.
I got this new shirt. I wear this periodically.
See what you did there?
Yeah, just like that, eh? So our second experiment to demonstrate density, we're putting on a new little twist.
Now, we're gonna just kick it up a notch by adding temperature into the equation. So, if you think back to the particle theory, Steigerites, basically temperature has an effect on the density of any substance, right? And why is that, Jeff Steiger?
Well, basically, if you add heat, right, particles become much more energized, become much more active, and they spread out, and they're chaotic.
Right.
And when you add cooling, or take thermal energy away, or take temperature away, they slow down. They become much more close together. So when you relate that to density, density being the amount of matter in 1 unit of volume, well, if your particles are all going nutty and you're spreading out, well, there's less particles in 1 unit of volume. Whereas when you cool things down, the particles get closer, they calm down, and therefore there's more of those particles in that unit of volume. Does that make sense?
It totally does. I mean, you know, it's too bad that we don't have a way of demonstrating that. It would be really cool.
We do. We do.
Ask and you shall receive.
Yes. So, what we are going to do is, because we are going to create an underwater volcano. Did you know Chuck Norris, he built a volcano for one of his grade 8 science fair projects. And after he won first prize, he threw the volcano in the Pacific Ocean. That's how Hawaii was created.
I should have known that.
Yeah. Alright, so because we are doing a volcano, I'm going to add red food coloring to the hot water.
So red represents heat.
Yeah, of course. You gotta be all hot.
So I guess what we would assume then is that
Add more?
Sure. If the temperature is hotter, okay, the temperature is higher, the water is hotter, it will be less dense than cooler water?
It'll be less dense because the particles are spreading out much more energy, therefore there's less particles, less density.
Okay.
So there's our volcano water. Now what I'm going to do is fill this up with just cool water.
Cool.
Very cool. So just fill this guy up with cool water. I'm going to fill it up to about 450 mils. Sure. Now, watch this. I don't know if the camera crew want to get a close-up of this, if they want to walk over here. So, I have to, well I don't really have to do anything, but I want to, but I'm going to dip this in this hot water that's colored with red. Let's fill it to the top.
Okay.
When I pull it out, I do not want any air space inside that little small beaker. I want to make sure the fluid's right at the top. I'm going to put that inside this beaker. Pretend this is the Pacific Ocean. It's cool water, right? This is hot water.
Interesting. So won't it just mix? Or you just get kind of a pinkish water?
I don't know. If this is cool water, this is hot water, the hot water, because of density, should rise. Because this is cooler water, it's more dense, it should layer at the bottom. We'll see if that happens.
If that works, that's amazing.
Now, if you can get down and look at eye level, you can clearly see the volcano erupting up and you see the leveling. There is the hot water, there is the cool water. No mixing whatsoever. Temperature affects density. Now, what do you think would happen if we do the opposite with cold water? So here, I'm just going to fill it up with kind of warmish water. 450.
Warmish is the official scientific term in case you're wondering.
Yeah, just like that one that we did in the, I can't remember that other term you mentioned, but it was very scientific. So there's that one there, we'll leave it there. For the cool or the cold water, I'm gonna add blue food coloring.
Oh, I get it, right?
Because it's cold.
So this is kind of like Arctic.
Yeah, glacier.
Chili.
Yeah, hiking on the glacier. So we'll just mix it up. Now we got cold water. Brr. So we're predicting that this blue, cold water, because it should theoretically be more dense, sink to the bottom. And this being warmer should be layering at the top. Here we go. Focus on, yep. All right, here we go. Making me laugh. Now, what is kind of cool is what this camera guy, I forget his name, shouted out. Splitsky. What Splitsky said is that because it's cold water, it should sink to the bottom, not layer on the top. There is a little bit of fluid that came out of the small beaker, but it did what Splitsky said. It sank to the bottom. But look what's happening to most of the cold water.
It can't even get out of it.
It's not leaving the beaker. Volcano, no volcano. Out of the beaker, in the beaker. All right, so there we go, density.
Beautiful formula. Mass divided by volume. I think we made some gains here today.
Yeah, real gains. Yeah, but oh, we gotta go to Best Buddies. I might as well finish off by sampling a little bit of Volcano. Oh, you're back.
Well, hang on, I can't miss this.
Oh, okay.
And just remember, Steigerites, never drink your experiments.
Yeah, don't ever taste it. Cheers.